Welcome everyone. Today I will be performing the DLIC experiment 1, that is the design of inverting and non-inverting amplifiers. First I'll be creating the inverting amplifier. We'll be using an OP07 op amp. For an inverting amplifier, we'll connect the voltage source to the negative terminal of the op amp, and we'll connect the positive supply to the ground potential. We will be keeping the positive and negative voltage supply for the op amp as 15 volts. This will be our this will be our feedback resistance. This is the input resistance, and this will be the ground resistance. Connect the ground and the resistance. Connect the feedback resistance appropriately. Now I'll create the voltage supply needed for the power supply of the op amp, the positive and the negative power supply. For making the circuit as clean as possible, I'll be using a label net. I'll label the positive as VCC and I'll label the negative side, sorry, I'll label the negative side as VEE. Ground this. So in this circuit, we will be using a gain of 4.8. So we'll be giving the feedback resistance 4.8k resistance ohms. Sorry, we forgot to put the voltage in the input side. We can move the ground using this. I'll give the input resistance as 1k so that the gain remains 4.8. As we know, in an inverting amplifier, the gain is given by Rf upon Ri, and here the Rf is the feedback resistance, that is 4.8, and the input resistance is 1k, hence we'll have a gain of 4.8. I'll give this as 1k as well. Now I'll give the positive and the negative power supply of the op amp as 15 volts. Now our circuit is ready for simulation. I'll do the transient analysis. I'll give the DC, I'll give the voltage supply as a sine wave by giving the DC offset as 0, amplitude as 1 volt peak, then and frequency as 1k. By giving a 1 volt, we'll get a 2 volt peak to peak graph. Now I'll be doing a transient sweep. The stop time would be 0.005 seconds. I'll place the scope first in the voltage to see how the input is. As we can see, it's 1 volt peak, 1 volt in the peak and 2 volt peak to peak. And if I connect the scope to the output, I can see that the output is amplified, and we'll have a 4.8 above and 4.8 below, that is total 9.6 peak to peak. In this input voltage, we have still not reached the saturation point. To reach the saturation point, we need the output more than 15. So if I cancel this and make the input as 5 volts amplitude and apply the transient sweep, I can see the input as 10 volt peak to peak, and in the output it would be saturated. As you can see the flattening here. Okay, so now I'll be performing the non-inverting experiment. For the non-inverting, I'll use the same components. This will be the feedback resistance, this will be the input resistance, this will be the okay. So now in this, we'll not be using a resistance for the non-inverting side. We'll just use the inverting side as the we'll just connect the inverting side with the resistances. We connect the ground here. We'll find the voltage source. We connect the components. As we know, this is a non-inverting. We connect the voltage source to the positive terminal of the op-amp and will ground the non-inverting terminal. The feedback loop will still remain connected to the non-inverting side of the amplifier. Now we'll connect voltage supplies for the op-amp for the positive and the negative side. Same, we'll be using a label tag VCC and VB. Now we'll be assigning the values. As we know, in non-inverting amplifiers, the the gain is given by 1 plus Rf upon Ri. So in this case, to get a gain of 4.8, we'll be giving the Rf as a 3.8k and Ri as 1k, and I'll give the DC value as 1 volt. Sorry, I'll give a sine wave in which the DC offset will be 0, amplitude will be 1 volt, and frequency 1k. I think now the circuit is ready for simulation. I'll perform the transient analysis. Okay, I forgot to give uh, 15 volts and 15 volts for the negative and positive supply. And now I'll perform the transient analysis. Stop time would be 0.005 seconds. Now I'll put the probe in the input. As you can see, I get a 2 volt peak to peak. Then if I put in the output, I can multiply the gain, that is 4.8 into 2 volt peak to peak, and I get a 9.6, that is 4.8. You can also trace it with this, as you can also verify the values. 4.8 peak, hence we get a 9.6 peak to peak. To get the saturated output, we can change the input voltage amplitude as 5 volts, and as it surpasses the value of 15 volts in the output, we should get a flattened wave. This is the input, this is the output. As you can see, there is flattening of the curve as it reaches the saturation here. Yeah, and I have made the table here for similarly for all the voltages, input voltages for both inverting and non-inverting amplifiers. And for 5 volts, I get a 10 volt peak to peak, and basically theoretically it should be 48, but it cuts off at around 27.9 peak to peak as seen over here, above 14.9 and below, and hence we get around 27.9 voltage peak to peak in both the cases. Thank you.